Good afternoon, students. Today we discuss the topic on diffraction. I think it's the third unit of our optics and spectroscopy unit. Okay. So in this diagram, the wave source it should be moving in a spherical wavefronts. This is actually is called as a spherical wavefronts. The wavefronts is nothing but the particles is moving in a one particular spread of waves. Okay, so it should be moving inside the particular opaque space. It's a two opaque space. There's nothing but a particular opaque space is placed with the two thin slit. In the thin slit, the particle is getting okay. So the light is getting diffracted. Is getting the bending of images in the obstacle is called diffraction. So during the diffraction, there will be a particular the bending of image is shown here. So it will have some diffraction pattern on the screen. Okay, just like the screen will have some, the intensity is going to be like this. That's the penetrating of the two light intensities, and this type of intensities, this intensity is going to be sorry, if an object is placed in a source of light and a screen, where sharp image is obtained on the screen. Okay. Okay. There is no lenses to use to make a parallel convergent. The waveforms will have either spherical or cylindrical. The final waveforms is going to be a spherical or cylindrical. So this type of propagations, this type of phenomena is called Fresnel diffractions. If suppose the Fresnel diffractions, there is a three types of source. One is source, obstacle, and the screen will be put in infinite distances. இப்போ இதுக்கு உதாரணம் பார்த்தீங்கன்னா நம்ம சாதாரணமாக ஒரு ஸ்க்ரீனு அப்டக்கல் ஸ்க்ரீன் அப்டக்கல் ஸ்க்ரீன் சோர்ஸ் எல்லாம் ஒரு ஃபைனட் டிஸ்டன்ஸ்ல இருக்கு. இப்போ உதாரணத்துக்கு இது வந்து டிவி ப்ரோக்ராம் வந்து டிவி செட்டப்பை வந்து ஃப்ரெனல் டைஃப்ராக்ஷன்ஸ்க்கு ஒரு உதாரணம் சொல்லலாம். ஃப்ரெனல் டைஃப்ராக்ஷன்ஸ்க்கு என்ன எக்ஸாம்பிள் சொல்லலாம் அப்படின்னா சூரிய ஒளி வந்து நம்ம இந்த இடத்துல ரீச் ஆகுதுல பாருங்க, நம்ம எர்த்துக்கு ரீச் ஆகுது இல்லையா, ஸோ அதை வந்து Fresnel diffractionsக்கு எக்ஸாம்பிளா சொல்லலாம். But here there is a lenses will need to make a beam is to be a convergent or divergent. Okay, if you make a beam is to be a parallel or convergent, we need extra lenses L1 and L2 will be needed to receive the parallel beam of light. Okay, thus the two lenses more effectively move source to a screen as to infinity. If you have to putting the source image and all the things will be putting in infinite distances, so they make a particular fringe pattern. So the incident plane wavefront is going to be a plane. The incident plane wavefront is going to be a plane wavefronts. But here the spherical and the cylindrical wavefront is obtained, but here the only the plane wavefront is obtained and the resultant beam. Okay. But there is some basic illustrations of about diffractions. These are the white light source. This actually diffractions creating. The diffractions creating will be putting a particular dispersion of the lights is going to take place. If you go direct violet to red color, Vibgyor spectrum is to be obtained on the screen. But that is the source of inspirations of diffractions pattern. So this is a good example for diffractions. Okay, if suppose we have using in our laboratory the white source as a be in a collimator in a spectrometer table, we put on a grating. The grating will be disperse the particular white light into Vibgyor spectrum because of diffractions phenomena. Because each one of the line will be acting as a one of obstacles. So in between the two obstacles, there is a small transmitter, there is a polyester surfaces. This polyester surfaces is easily diffracted as well as dispersions is going to take place. Automatically the Vibgyor color has been obtained in the screen. And also the another example is we just putting a rainbow. Rainbow is also one example of one particular examples of diffractions. So if you know that each one of the liquid drop will be acted as a lenses. If sunlight is to be getting into the raindrop, getting into the clouds, it automatically there is a diffraction as well as total reflection has been takes place. If it will have the each one of color is getting dispersed as a diffraction also takes place here. So they would make the Vibgyor color has been seen in the clouds. So there is another good example of day-to-day activities. Okay, so there are so many illustrations based on the diffractions phenomena. And also this is a summary of this today's talk is just how to the bending of images in the obstacle is called the diffractions. Okay, the diffraction because of the diffractions, the diffraction is classified into Fresnel diffraction as well as Fresnel diffraction. Fresnel diffraction is source, obstacle, and a screen will be putting in a finite distances. Source, obstacle, screen will be infinite distances called a Fresnel diffraction. There is no lenses will be needed for Fresnel diffraction. There is lenses will be needed to getting the light is to be convergent or be parallel planes. This spherical wavefront is a spherical or cylindrical. This spherical wavefront is a plane. So these are the differences of the Fresnel and Fraunhofer diffractions. So here in this diagram, in our day-to-day activities, this is also a diffraction pattern. Here, the source of light is a sunlight. Here, our window is to be acting as a diffraction obstacles. So there is a small slit to be here. This, inside the slit, the light is be easily bending into. There might be a diffraction images in that flow. So we just to be intimated that we just to be seen in the day-to-day activities. So this is actually a diffraction pattern because of the light is be bending in the obstacles. Okay, so these are the source of inspirations of our natural physical phenomena. This diffractions phenomena is one innovative things it have used to generating the new instrumentations like new instrumentation like X-ray diffractometer as well as a scanning electron microscope and tunneling electron microscope. This is based on this devices is to be manufactured by using the principles of diffractions. Okay, so these are the more informations about the minute crystals and also the minute microscopic objects. We know all idea about the particle, how the particle can be arranged inside the one particular volume of the atom. So many informations we got to get it from the this idea. Okay, this is a very marvelous idea in regarding the physics concepts. The technological point of view, it's very much useful to developing more instrumentations based on that. If there is any queries, please ask. I slightly define the diffraction as well as what is a classification of diffraction phenomena and some illustrations. So these are the things we'll discuss today. So if you have any queries regarding this, please arise. Okay. Okay, I stop here. Thank you very much for your patient listening.